let's talk about some things that are kind of related to size or sizing. Like Dale specifically asks us about instance sizing. There's one category of things I noticed here are load balancers, Ned. So we've got, and that is an instance sizing, right? Load balancing is more about scaling out. But
Right.
instance sizing is kind of more, in my mind, scaling up. Getting the right size scale for your workload. But I decided to throw load balancers in here. There are three kinds, not the details of which are subtle to me. You've got the elastic load balancing, which has been around forever. You've got the application load balancer, which is more about HTTP, HTTPS traffic, seems more, layer 7 magic you can do there. And then the network load balancer, which is somewhere in the middle. You've got TCP traffic, where extreme performance is required, as AWS says in the PDF. So starting there, Ned, ELB, application load balancer, network load balancer, you want to compare and contrast these three?
Sure. ELB is the classic service. It comes from before there were VPCs, when there was just EC2 and you needed a load balancer to put in front of them. And then they sort of ported that into VPCs. And so it absolutely works with those. And it works sort of between layer 7 and layer 4. So it has some features of both, but it doesn't necessarily do either of them especially well, which is why they developed the application load balancer and the network load balancer. So the application load balancer, you're absolutely right. That is a layer 7 load balancer. That is what it's intended for, but it's more of a single tenant deployment, by which I mean it will scale up, but there is some lag in it scaling up. So if your traffic spikes really fast, your application load balancer might not be able to keep up with that. So that's something to bear in mind. But it does add a whole bunch of useful layer 7 processing logic that didn't exist in the ELB. So it allows you to serve multiple domains from a single IP address. It allows you to do SNI with certificates. So you can have multiple certificates for a particular IP address, and then it'll look and see what server name are you asking for. Oh, I will give you the proper certificate for it.
Well,
So
I was actually curious about that. Is the ALB as the my front door into my application server farm, is that where my SSL terminates, or could be sort of a proxy?
Typically, yes, you would terminate your SSL at the application load balancer, and then it's optional whether you want to re-encrypt coming out the back end.
Yeah.
A very solid argument could be made that the traffic that flows out of the back end is within your VPC. So assuming no one's compromised your VPC and found a way to sniff traffic, you should be okay. But if you really want to encrypt, you can just use the self-signed certificate, because it's really not that big of a deal at that point, and away you go.
But that feels very like I was an F5 physical load balancer person back in the day, and we had a bunch of applications that, depending on what the regulatory requirements were, for example, we maybe didn't re-encrypt on the back end, but we do SSL termination on the F5, and then make up our minds on the back end. And this application load balancer from AWS feels the way they've designed it very similar.
There was a time when compute resources were so precious and the capability of doing decryption and encryption had to happen on the CPU and not on the NIC, which is a lot of NICs do the offload now. So you were very concerned. I want to do the decryption at the load balancer, which has specialized, silicon to do that, and then leave it unencrypted when it's hitting my web instances, because I don't want to burn their CPU cycles doing that dance. That is not nearly as much of a concern now.
Right.
The network load balancer is very different. It is a layer 4 load balancer. It is
so we classic elastic load balancer. Then we went application load balancer. Now this is the third one, the network load balancer.
This is the third one.
Okay. Yep.
So the network load balancer is multi-tenant, and you don't have to scale. It can basically handle whatever you throw at it. So you can throw as much traffic as you want, and AWS just processes it and just chunks through it. What that means is it's good for quote unquote extreme performance situations. That's what they mean by extreme performance, is throw as much traffic at it as you want. We can process it. What it doesn't offer is anything above layer 4. So it's not going to do the SSL decryption and re-encryption to the servers behind it, they are actually seeing the client IP, and when they respond, they're responding to that client IP. It's still going back through the network load balancer through, some magic, but that network load balancer is not it's not changing the packets in any way. So that's also important to know about the way that it handles the traffic. One of the design patterns that you can do is have the network load balancer sit in front of application load balancers to do that initial triage and direction of things, and then have the application load balancers do your layer 7 stuff, and then have it hit your EC2 instances.
So it hits the network load balancer. The network load balancer would spray across several different application load balancers potentially.
Mm-hmm. Yep.
And then from there, so in your application load balancer, you do your fancy L7 stuff, HTTP header rewrites, or whatever the SSL and so on, whatever the fancy HTTP stuff is you need. Then it goes back to I don't want to have to troubleshoot that, but I get the application architecture. Yeah.
Yes. And that's one of those things, like whenever you're designing, you have to design at a level of complexity that you're comfortable with, because you're going to be the one who has to administer this system and troubleshoot it when something goes wrong. So you might get the best performance by throwing the network load balancer in front and then passing it through an application load balancer. But yeah, you're going to have to troubleshoot all that. So just bear that in mind.
And of course, you got to pay for it.
Right. Probably don't use the classic load balancer. They're trying to deprecate that. So they really only want to support it for legacy environments. And, as you're building net new, they are really pushing you towards selecting one of the other two.